Welcome back. This is part 2 of AI agent loop patterns. In part 1, we stayed close to the core idea. Think to act to observe. Then we added conversation, user-visible narration, and parallel tool calls when work is independent. In part 2, we go one level deeper into how real agents stay useful when tasks are messy, long, or easy to get wrong. First, Iterative ReAct, the same loop repeated on purpose, one step at a time until the evidence points you somewhere new. Then ReAct plus reflection. After you act, you pause and critique. Did that work? Before you retry with clear limits, so reflection doesn't run forever. Next, memory. Tool outputs are fleeting unless you persist them. We'll cover what to store, episodic versus long-term persistence, and how bad memory silently poisons future steps. Finally, planning. A high-level roadmap first, then mini ReAct loops per step, and why replanning matters when the first plan meets reality. I'll anchor each pattern with a concrete developer-style example, so it's not abstract theory. If you're new here, part 1 is linked in the description, but you can still follow part 2 if you already understand basic ReAct. If this helped, like and subscribe. It pushes the lessons to people who actually care about the topic, and you'll catch the next videos in this series. It costs you nothing, but it means a lot to me and my team. If something clicked or you have a question, leave a comment with your use case. I read comments, and they steer what I publish next. To learn more about me, visit this page. For agents, RAG, MCP, and related pages, visit this page. Same links are below in the description and pinned comment. Iterative ReAct is the normal ReAct loop used with deliberate repetition. The agent does not try to solve everything in one big step. It takes one action, observes the result, updates its understanding, and then takes the next action. The loop is think, to act, to observe, to think again, to act again, to observe again to result. This is useful when the task is unclear at the start. For example, a coding agent may first inspect the files, then read the relevant function, then check the error, then make a fix, then run tests. Each observation changes the next step. The benefit is control. The agent can adapt as it learns more. It does not need the full answer up front. The downside is latency. More iterations mean more model calls and more tool calls. So you need limits, max steps, timeout, retry caps, and a clear definition of when the task is done. Use Iterative ReAct when the agent needs to explore, debug, investigate, or solve something step by step. Example, my API returns 500 error when creating a user. Think, I need to investigate the error step by step. Act, call API endpoint to create user. Observe, 500 internal server error returned. Think, I should check server logs. Act, fetch backend logs for create user function. Observe, error shows, cannot read property email of undefined. Think, input validation might be missing. Act, inspect request body handling in controller. Observe, no validation middleware is applied. Think, fixes to add validation for request payload. Act, add validation middleware and redeploy. Observe, API now returns 201 created. Final result, bug fixed by adding missing request validation in user creation flow. ReAct with reflection adds a self-checking step. The loop becomes think, to act, to observe, to reflect, to maybe retry, to repeat if necessary, to final result. After the agent completes an action or attempt, it reviews what happened. It can ask, did this solve the task? Was the result correct? What failed? What should I do differently next time? This is useful when the first attempt might be wrong. For example, a coding agent might write code, run tests, see a failure, reflect on the error, and then try a better fix. Reflection improves robustness, but it has a cost. Every reflection step is another model call. and reflection is not magic. The model can still misunderstand the problem or overcorrect. This pattern needs clear stop conditions. Without limits, an agent can reflect and retry forever. Use reflection when quality matters and the task is complex enough that a single pass is not reliable. Example: fix the bug where my function returns NaN when dividing numbers. Think, I need to inspect the division function. Act, run the function with test inputs, 10 divided by 2, 5 divided by 0, 0 divided by 5. Observe, 10 divided by 2 equals 5, 5 divided by 0 equals NaN, 0 divided by 5 equals 0. Reflect, division by 0 is not handled, which causes NaN. This is incorrect behavior. Think, I should add a guard clause for division by 0. Act, update code to return 0 or error when denominator is 0. Observe, tests rerun successfully, no NaN values. Reflect, fix is correct and stable, no further changes needed. Final result, bug fixed by handling division by 0 cases properly. ReAct with memory adds persistence. Normal tool observations are temporary. The agent sees the tool result during the current run, but unless you store it, that information disappears. Memory changes that. The loop becomes think to act, to observe, to read, /write. Memory to final result. Memory can store user preferences, previous decisions, summaries, task history, or useful facts. For example, the user prefers short answers. This project uses next.js. This API failed before with this error. The previous solution was rejected. Memory helps agents work over longer sessions. It can reduce repeated questions and repeated tool calls. Short-term, episodic memory stores recent interactions within a session, like what just happened in the current task flow. Long-term memory stores stable, reusable knowledge across sessions, such as user preferences, project context, or recurring patterns. But bad memory is dangerous. If the agent stores something incorrect, stale, or too broad, it can poison future decisions. So memory needs structure, cleanup, scope, and sometimes expiration. Use memory when the agent needs continuity across steps, sessions, or users. Example: help me continue my API project. Think, I should check if I already know anything about this project. Read. Memory. Project uses next.js. API previously had auth issues. User prefers short, clear answers. Act, load project structure. Observe, found Nest.js backend with JWT auth. Think, I should store this new context for future use. Write memory. Current backend framework, Nest.js. Auth system, JWT based. Think, now continue with relevant suggestion. Final result, I suggest improving JWT refresh token handling in your Nest.js API. ReAct with planning adds a planning step before execution. The loop becomes input to plan to execute each step, with ReAct to observe to repeat, if necessary, to final result. Instead of jumping directly into tool calls, the agent first creates a high-level plan. For example, understand the request, find relevant files, inspect current implementation, make the change, run checks, summarize the result. Then each step can run its own think to act to observe loop. Planning reduces random tool use. It gives the agent direction and makes complex tasks easier to manage. The weakness is that plans can be wrong. If the first plan is bad, the agent can waste time following the wrong path. That is why strong systems often need replanning. After new observations, the agent updates the plan. Use planning for long tasks, multi-step workflows, research, coding, data analysis, and anything where order matters. Example: refactor my authentication module and make it more secure. Input: refactor authentication module for better security. Plan: 1. Inspect current auth implementation. 2. Identify security weaknesses. 3. Update JWT handling and password hashing. 4. Run tests. 5. Validate security improvement 6. Summarize changes. Execute step 1. Think, I need to locate auth module. Act, open auth service and controller files. Observe, found JWT auth with basic password hashing. Execute step 2. Think, check for weaknesses. Act, review password hashing logic. Observe, passwords are using weak hashing, MD5. Execute step 3. Think, improve hashing and JWT handling. Act, replace MD5 with bcrypt, update token expiry. Observe, code updated successfully. Execute step 4. Think, verify changes. Act, run test suite. Observe, all tests pass. Final result, authentication module refactored with stronger password hashing and improved JWT security. That wraps part 2. The through line here is bigger than memorizing names. It is recognizing when evidence should change the policy of the agent. Iterative ReAct is for exploration. Tighten the belt with step caps, timeouts, and a crisp definition of done, or you pay latency for every extra loop. Reflection is for correctness under uncertainty. Critique after observe, retry with purpose, then stop reflecting when the trajectory is stable or your budget hits 0. Memory is continuity. Episodic glue inside a session, longer-lived facts outside it, and garbage in stays garbage out, so isolate scope versioning, TTLs, or cleanup. Planning is sequencing. Shrink aimless tooling with a roadmap, then expect replans because the real world violates the initial outline. Together, those 4 knobs turn a brittle demo into something you can iterate in production with fewer surprises. Not because every pattern is flashy, but because your loop earns you evidence before you compound the wrong commitments. Next in part 3, stronger reasoning, chain and tree of thought layered on top of loops. Test in sandbox before you touch prod. Learning from feedback with guardrails, and a short landing on trade-offs. What to add only when your product proves it cannot ship without it. If this helped, like and subscribe. It pushes the lessons to people who actually care about the topic, and you'll catch the next videos in this series. It costs you nothing, but it means a lot to me and my team. If something clicked or you have a question, leave a comment with your use case. I read comments, and they steer what I publish next. To learn more about me, visit this page. For agents, RAG, MCP, and related pages, visit this page. Same links are below in the description and pinned comment.